All right. Good afternoon. Good afternoon. I am Dr. Boyd, the chemist, and we are doing this is the fourth week of our homeschool science lessons. I hope this has been a benefit to you, to the parents, and to the students and the children out there. Today, we are doing an experiment called the rubber egg. Rubber egg. And I hope you all can see that. Sorry about my lighting in here today. All right. What you'll need is one raw egg. Now, I realize eggs are limited right now, so if you just want to follow along, you can do that. But if you want to participate and do it in a hands-on fashion, you'll need one raw egg. You're going to have to sacrifice the egg, vinegar, and a glass. All right, and we'll get started in about a minute or so. Good afternoon, Stargels. I hope you're enjoying this. Hey, Aunt Chris. All right, we can go ahead and get started. And once again, I'm Dr. Boyd, the chemist, and this is lesson 16. Lesson 16, and just a heads up, we will be doing an entire week worth of lessons, and we already have the syllabus out and the plan out. If you haven't checked it out, do check it out on Instagram at sciencemadesimple_LLC. And I've posted it there. I've also posted on LinkedIn and on Facebook and on Twitter. If you want to follow me on Twitter, I'm Dr. Boyd_chemist. And if you want to follow me on Instagram, again, sciencemadesimple_LLC. And definitely, if you want to check out my YouTube channel, I have lots of videos. And in fact, I posted a new video this morning based on one of the experiments that we did, I think 2 weeks ago, with celery and changing the colors of it. So that was posted this morning. And so you can follow me on YouTube just search for Dr. Boyd the Chemist, and I'll come up. And definitely subscribe. So today, we got the Wilsons in the house. Today we got rubber egg is our experiment, and you'll need a raw egg, vinegar, and one glass. And so when I say a glass, you'll need just a glass, something you can fit an egg into. And the vinegar that you'll need, got some vinegar here. You'll only need enough vinegar to fill up the glass, enough that it covers the egg. All right, and I'll discuss that a little more later on. But the topic today, the thing that we'll be discussing, is this word called osmosis. That's one word, osmosis. I'll write it down for you so you can see how it is spelled. And after today, you can look it up if you so desire. Osmosis. All right, this is how you spell that. Osmosis. 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 Now, before we get into our discussion of osmosis, let's review what the most important thing is about scientific experimentation. What is the most important thing for a scientist to pay attention to whenever they do an experiment? What should I be paying attention to? Now, if you said safety, you are 100% correct. There's nothing more important in the laboratory than safety. Nothing more important. Nothing's more important than that. I must be safe no matter what experiment I'm doing. And I have to think about the safety rules, the things I should be considering in order to be safe for every individual experiment. So if I did an experiment today and I pay attention to the safety protocols of that day, the next day, if I do a totally different experiment, there may be different safety protocols that I need to pay attention to. And so I have to think about that for every single experiment I do. All right. Now, today we're dealing with an egg, vinegar, and a glass of water. So you don't see me wearing my personal protective equipment because it's not necessary for this experiment. What is personal protective equipment? You remember? All right. I want to protect my eyes. So I'll wear goggles or safety glasses. I want to protect my hands. So I wear gloves. And I want to protect my body. So I wear a lab coat. All right. That is very common, typical safety equipment to wear, or what we call personal protective equipment. You hear that term a lot, especially nowadays, PPE. Okay, that's what that stands for. Now, I could wear splash goggles today because we are dealing with a liquid that is not water. We're dealing with vinegar, but I know that the vinegar is not very concentrated and the likelihood of it splashing in my face is not very great. But as an extra precaution, if you choose to wear goggles, that will be perfectly reasonable. Okay, so today I have with me my lab notebook. Why do I have this lab notebook? Do you remember the importance of a lab notebook? I want to write down what it is that I'm doing that day. I want to write down any questions I have before I do my experiment. And then I want to write down my hypothesis. I want to write down what I think the outcome will be because I want to be able to assess it. Okay? Now, what is the topic for today? We know that the experiment is called the rubber egg experiment. And we also know that the topic is that word osmosis. So for those who didn't have their notebooks a moment ago, hopefully you have it now. I'll show you this word again. This is what we're going to discuss. Osmosis. OSMOSIS. Make sure you write that down in your notebook. The topic, the rubber egg, or experiment, the rubber egg, and the topic, osmosis. Osmosis. All right, so now we're ready for this experiment. And let's think about this. A couple weeks ago, we did 2 days on a topic called diffusion. Diffusion, all right? Do you remember what the definition of diffusion was? All right, maybe not. I think that was the very first week. That was lessons 4 and 5, I believe. So diffusion is the movement of particles from an area of high concentration into an area of low concentration. All right, the movement of particles, and really there's this word we use in science, spontaneous. So it's just going to happen. The spontaneous movement of particles from an area of high concentration into an area of low concentration. All right, that's diffusion. I'll say that one more time in case you want to write that down. The movement of particles from an area of high concentration into an area of low concentration. All right, that is diffusion. I'll write diffusion down too for those who don't know how to spell it. All right, diffusion, DIFFUSION, diffusion. And again, I believe those were lessons 4 and 5. I should make a point of saying that I have posted the first 10 lessons from the first 2 weeks on my YouTube channel. If you want to go back and review them, or perhaps you missed one, they're posted there on my YouTube channel. Again, get on YouTube and search for Dr. Boyd the Chemist. You can watch the videos, the full-length videos that we recorded here while we were doing this live stream. They're all posted there. Lessons 11 through 15 that we did last week will post on Thursday. They're already uploaded. I just set them to post on this Thursday, so people had time to digest what we were doing this week and what we did the first 2 weeks. All right. So diffusion, the movement of particles from an area of high concentration into an area of low concentration. Now, today we're talking about osmosis, and the definition will sound very similar, but there's one major difference, okay? Osmosis is the movement of a solvent through a semipermeable membrane, an area of high concentration, through the semipermeable membrane into an area of low concentration. Okay? I'll write that word semipermeable down. Let me erase a couple words here. I'll write that down because this is a key distinction. Now we don't just have the movement of all particles, we have the movement of just a specific solvent from the area of high concentration through the semipermeable membrane into an area of low concentration. So I'm going to write that word down. And I apologize, we're using a lot of big terminology here today, but I hope that it makes sense when we're all finished, all right? So semi-permeable, and I'll leave that up for a little while so that you can write it down. So the definitions are very similar, but the distinction between, the major distinction between diffusion, which was the movement of particles from an area of high concentration into an area of low concentration, the difference between that and osmosis, which is the movement of a solvent through a semi-permeable membrane into an area of low concentration. So the solvent is in high concentration area, it moves through this membrane into an area of low concentration. I just realized I didn't write down membrane. Let me write that down in case you don't know how to spell it. All right, so again, the distinction between diffusion and osmosis is the semipermeable membrane. Okay? What does that semipermeable membrane do? All right? Well, when I say the word permeable, what that means is things can go through it. You can pass through it. It's permeable. You can pass through it. When we say semi-permeable, what that means is some things can pass through, other things cannot. Okay? So semi-permeable, not everything can pass through that membrane. Some things can, however, pass through that membrane. What determines whether or not something can pass through? Once upon a time, I worked in a biochemistry lab and we had membranes and we were trying to get rid of certain things and we were trying to collect or concentrate other things, okay, in these membranes. And one of the things that can determine whether or not a membrane is semi-permeable is the size of the molecules that you are trying to pass through that membrane. All right, the size of the molecules can determine whether or not something can pass through a membrane. All right. So again, osmosis, we have a solvent that is in an area of high concentration, passing through a semi-permeable membrane into an area where the solvent is in low concentration. All right. Now, today, our semi-permeable membrane actually is all around this raw egg. Okay. So again, if you don't want to sacrifice eggs, because I know resources are low and I think stores are in low supply of eggs, so I understand, but you can watch, I've done this for you, and I'll explain. This raw egg here, and I'll prove that it's raw and that it's still in its shell, because that'll be something you might question later on as this discussion continues. I have a plate here so you can hear the sound of the egg. All right, so I have this egg here and in this plate, and this egg on the inside is the raw yolk. I haven't boiled this egg, so it's the raw yolk on the inside. You can't feel it shaking around inside, but trust me on that. So this is a raw egg. Well, on the outside of that, the egg and everything on the inside of it is the shell. Okay? Believe it or not, the inside of an egg has some water in it, but there's also other things in there, right? The proteins and the parts of the yolk and the albumin and all of these things, okay? So those are on the inside, but there is some water, all right? Then we have the shell. And believe it or not, you can actually pass water from the outside into the inside of the shell. And that is what we'll be demonstrating today. And that will be the process of osmosis. So around what we think of as the egg, the inside of it, the part that for those who eat eggs, the part that we eat is on the inside there, and on the outside is this hard shell. We can get water to pass from the outside, though, into the inside. All right? That is what we'll be doing today. So here's how you'll do it. Take your glass, carefully, gently place your egg on the inside. All right. Whew. Carefully. Okay. And then you'll take your vinegar and fill the vinegar up to just the height of the egg. Now, what's going to happen, I will tell you, because I have done this for you already, is that the egg will actually begin to float. So you'll fill it up to what you thought was the top, and it'll keep rising. So the egg will begin to float. So you're going to need to fill it up just a little bit more than the length or height of the egg itself. And that way it'll be fully covered. Now, there's going to be a little part at the top that'll kind of sit out, and I'll explain how to deal with that in a moment. But I will tell you, I have done this already, because this experiment we cannot do in the time frame that we have allotted for today. It will take about 24 hours, so it'll be an entire day. So what happens when you allow the egg to sit in vinegar for an entire day? Well, I can show you. This is the egg. I put in vinegar, not quite 24 hours, about 18 hours. I did this last night, and watch this. It is actually, I can press into it. I don't know if you can see me pressing into it here. I can press into that egg. It is very rubbery. I'm still delicate with it, but you can see that it bounces. And it doesn't make that loud sound that my other egg, which I had not placed in vinegar. Be careful here. All right. So you can tell that this is the one that is raw, and this one is rubbery. Makes no sound. All right. Well, what happened when I placed the egg in its shell, raw, when I placed it in the vinegar, immediately it began to bubble up. It began to bubble up. All right. And the bubbles were formed because the eggshell is actually made of calcium carbonate. Vinegar, you may recall from our carbon dioxide experiment where we trapped the carbon dioxide in a balloon. Vinegar is actually very diluted acetic acid. When acetic acid and calcium carbonate get together, you end up with bubbles, much like when we added the baking soda and vinegar together, you got a lot of these bubbles. Well, those bubbles are forming because there's carbon dioxide gas being released. All right. So we have carbon dioxide gas, and they form all the way around the eggshell as the eggshell is reacting with the vinegar. Okay. So acetic acid from the vinegar is reacting with the calcium carbonate egg shell. You get all these bubbles. And eventually what happens is this really hard shell goes away, and you get this really bouncy, rubbery egg. Now, I was going to bounce it really high, but I kind of started this a little too late last night, so I'm a little concerned that it will still splatter everywhere. So I won't bounce it too hard. I'm actually going to put it back in vinegar and let it sit there for several more hours to see how rubbery I can actually get it. And I will be posting a video to explain this on my YouTube channel in the coming weeks, just because I think it's pretty cool. So we have this exterior of the eggshell that is actually permeable. Well, why is it that we get this rubbery effect? And also, why is it that, if you can tell, the rubbery egg, which is in this hand, is actually slightly larger than, it's hard to see it on the screen there, but this egg that's been sitting in the vinegar all night is larger than when I first put it in the vinegar. All right. That is because on the inside of the semipermeable membrane that covers up the egg, water's in there now, and it's kind of expanded. That's pretty cool, right? Why? Well, vinegar or acetic acid is actually mostly water. All right, it's mostly water. And as I mentioned before, the raw egg on the inside, there's a little bit of water. So there's a lot of water in the acetic acid, and there's a little bit of water on the inside of the egg. That is an area of high concentration of water surrounding an area of low concentration of water. And what happens with time is that the water from the acetic acid actually gets on the inside of the egg shell and begins to expand it, because now it's trying to reach a state of equilibrium such that there isn't such a disparity in the water content or concentration from the outside of the egg to the inside of the egg. All right, so let's review. Do you remember the definition of diffusion? Do you remember the definition of diffusion? All right, diffusion is the movement of particles from the area of high concentration into an area of low concentration. Now, what is the major difference between diffusion and this word that we learned today, osmosis? With osmosis, we have to have a semi-permeable membrane, okay, using which a solvent that's in high concentration can pass through into an area of low concentration. All right, so the big distinction between diffusion and osmosis, amongst maybe some other things that we won't get into today, but the big distinction is this notion that we have to have a semi-permeable membrane that allows some molecules through and holds other molecules back. Okay, semi-permeable. All right, that is our lesson today. And again, I know some of you maybe have sacrificed some eggs. If you sacrificed your egg for science today, along with Dr. Boyd, the chemist, what I would like for you to do is, when you're finished with this tomorrow, you take the egg and you clean it off and you play with it a little bit. If you make a video or if you show me a picture of the egg before and after, hashtag it and post it to Instagram, post it to Facebook, hashtag it Science Made Simple. That way I'll be able to see it and I get to see all the work that you all have done. If you weren't able to do it because you want to save your eggs, which I totally understand, I hope you learned something here today. And again, I will be posting a video to my YouTube channel where I more fully explain the science behind what is happening. And this week we have experiments. Tomorrow, all you will need is a piece of paper. We're going to talk about the science behind paper airplanes and how they actually fly. So tomorrow you will only need a piece of paper. We'll make an airplane. If you want to bring a couple pieces of paper, I might show you 2 different types of paper airplanes to make, but we'll talk about the concept behind paper airplanes and actually how they fly. So that's what we'll be doing with tomorrow. There are 3 other lessons after that this week. All of those are posted on Instagram and on Facebook, so you can see exactly what we'll be doing this week. And I will be posting what you'll need ahead of time. With that, I do thank you. Again, subscribe to my YouTube channel, Dr. Boyd the Chemist. Sign up for my Instagram page at ScienceMadeSimple_LLC. And I will see you here at 2 p.m. Eastern Time on Facebook Live and on Instagram Live. Hope you enjoyed this lesson. Take care.